Welcome back. I hope you found that animation helpful, and I hope you're an expert now in the different ways that the hypothalamus communicates with the anterior pituitary and the posterior pituitary. Hopefully you noticed on that animation that the person was facing the other way, so the positions of the anterior and posterior pituitary were reversed in our view. All right, let's examine what hormones the two lobes of the pituitary make. So we'll start with the posterior pituitary. The posterior pituitary only makes two hormones, and they are oxytocin and vasopressin. Those are the two names I prefer to use, but however, vasopressin is also known as ADH. On another slide, you'll see that written out. It stands for anti-diuretic hormone. And the interesting thing about vasopressin and oxytocin, if you ever care to read about this more in depth, is that they actually look very much alike. And they have many different roles, and they've been adapted for different purposes throughout the course of evolution in the animal kingdom. The anterior lobe of the pituitary makes several hormones, including growth hormone. I'm sure you've heard about this. If you do not have enough, if your pituitary does not make enough growth hormone, you may become, you might be a dwarf, a pituitary dwarf. I'm sorry, I didn't mean to release both of those. The gonadotropins are FSH and LH. Now, what do we mean by gonadotropins? The gonadotropins are the hormones that go to the gonads. So the gonadotropins go to the gonads, and in our next session, we will be talking a lot about FSH and LH. They stimulate the ovaries and testes. Again, it doesn't matter if you're a male or female, you have an anterior pituitary. Your anterior pituitary releases both FSH and LH. However, if you're a female, they will affect your ovaries, and if you are a male, they will affect your testes. But these are our gonadotropins. ACTH, this is a hormone released by the anterior pituitary that stimulates the adrenal cortex. And finally, we have the hormone we're going to talk a lot about, TSH, which stands for thyroid stimulating hormone. So I think you can even see right now that the pituitary gland makes hormones that affect other hormones, other endocrine glands, which then make other hormones. So today we're going to spend some time talking about the thyroid gland. Now the thyroid gland is the largest gland in your body. It's wrapped around your trachea or your windpipe. And again, the four parathyroid glands, which we will not have time to talk about, they are embedded in your thyroid gland. As we've already mentioned, the thyroid gland produces the hormone thyroxine. And as we've already mentioned, one molecule of thyroxine, I don't know why I'm having trouble with the pointer today, one molecule of thyroxine contains 4 atoms of iodine. So I don't know if you've ever gotten your thyroid levels tested, your thyroid activity tested, or maybe you know someone. If so, if you look at a medical report, they probably reported T4 levels. Well, the T4 means thyroxine because, as we've seen, thyroxine has 4 atoms of iodine in it. As I've also mentioned, the thyroid gland is the largest endocrine gland in your body. Now, here's an interesting thing about your thyroid gland. It can regenerate up to 90%. So let's say that somebody would unfortunately maybe find a growth in your thyroid and you'd have to have part of it removed. It can actually grow back over time. And now, I just really like talking about hormones, so I like to throw in a little trivia. You don't have to write this down or copy it or anything, but the thyroid gland was originally thought to beautify the neck and to keep it warm. People looked at it when they were doing autopsies on cadavers, and they just took their best guess. But what we are going to really focus on today is that the thyroid gland produces thyroxine, and what thyroxine does is it increases the rate of your metabolic reactions. So this is the take-home message, that thyroxine is the hormone that regulates your metabolic reactions. Now, an important thing we need to talk about, I am just having trouble with my pointer today. Why is this not page down? All right. Important thing we need to talk about is homeostasis. And an important instrument in maintaining homeostasis is negative feedback. So if you only have time to review one concept between this lecture, if you will, and the next, it should be negative feedback. And for today, we will define negative feedback as a hormone regulating its own production. So, homeostasis. Oh, I'm sorry. just on a roll today. The key feature of negative feedback, how you know it's this process is negative feedback and not positive feedback. Negative feedback always results in the diminishing of the original stimulus. Recall the very first or second slide. We said hormones are released in response to a specific stimulus. So in a negative feedback, the original stimulus, whatever that was, will be diminished or even reversed. So, as I've been hinting at, this is very process in maintaining homeostasis. It's really important for all animals to maintain a stable internal environment, but especially vertebrate animals. Our physiology is just so complicated, and there's a lot that goes into maintaining our homeostasis, and negative feedback is an important tool. So, just to review, our hypothalamus, you should know by now, is part of your brain. We've already mentioned that. We've already mentioned that blood vessels run through it. Now the next two items are new. Basically, your hypothalamus acts as the thermostat of your body. So this part of the brain, it's continually sensing whatever is in the blood that's passing through it. It monitors levels of various hormones. It monitors the blood glucose concentration. It's very, very important that your blood glucose levels do not get too high. That can damage your blood vessels and therefore your internal organs. It's very, very important that your blood glucose levels do not get too low. Your cells might not have enough energy. So your hypothalamus just measures monitors all sorts of things. Salts, oxygen levels, and what we will talk about in this situation is your internal body temperature. So let's say that on the way to class today, oh, by the way, we are now starting the second page of your lecture guide, and you see two little boxes there, the normal example of negative feedback and then the condition that produces the goiter. So we are now filling in the box on your left. So here's our little story here. You were just out in a thunderstorm and you came in and you are cold. And so you have a low body temperature, and your hypothalamus senses that. So the low body temperature, this is the stimulus. And then, of course, as the result of a stimulus, there's a response. In this case, the response is the hypothalamus releases a hormone, which is called a releasing hormone. Specifically, it's called thyrotropin releasing hormone. This name will make more sense to you in a minute. All right. TRH, or thyrotropin releasing hormone, goes directly to the anterior pituitary. Remember that there are little capillaries that extend from the hypothalamus to the anterior pituitary. So these little releasing hormones, sometimes they're called releasing factors, these little releasing hormones go and stimulate, they in turn stimulate the anterior pituitary to release one of its hormones, ta-da, TSH. TSH stands for thyroid stimulating hormone. So, like all hormones, thyroid stimulating hormone is released into the bloodstream. Now, it's easy to say, TSH goes to the thyroid gland, but in reality, it's just secreted in the bloodstream and it circulates throughout the entire body. However, the receptors for TSH are only found on the thyroid gland. So, the anterior pituitary secretes TSH, which circulates throughout the blood, and it stimulates the thyroid gland to do two things. The first thing it stimulates the thyroid gland to do is mitose. So the first thing it stimulates the thyroid gland to do is mitose, randomly the first thing. And the other thing that it stimulates the thyroid gland to do is to secrete thyroxine. Thyroxine enters the bloodstream, it affects cells all over the body, and it raises your body temperature. So notice this actual stimulus here has been diminished or reversed. Low temperature started this all out, we've raised the body temperature. Since we have a higher body temperature, the hypothalamus is no longer stimulated to release TRH, therefore the anterior pituitary is no longer stimulated to release TSH, and TSH is no longer stimulating the thyroid gland to mitose and release thyroxine. So this is an example of a negative feedback loop, and you can see how it's very effective in keeping thyroxine at very specific levels in your blood. Negative feedback loops keep glucose levels at very specific concentrations in your blood, etc., etc. Now, I like this picture because up here we just hit a bunch of words. I want you to try to visualize this in the human body. So again, your hypothalamus is part of your brain. So here is the hypothalamus in this woman's brain. Let's say she's getting cold. The hypothalamus sends TRH directly to the anterior pituitary because there's those little capillaries. The anterior pituitary releases TSH, but it doesn't go directly to the thyroid gland. Thyroid stimulating hormone is secreted into her blood, and it travels all throughout her body. However, the target cells are on the thyroid gland, are in the thyroid gland because that is where the receptors for TSH are located. TSH stimulates the thyroid to do two things, to mitose and to produce the hormone thyroxine. Again, thyroxine is secreted into the bloodstream, and it stimulates cells all over the body to increase the body temperature. So again, thyroxine controls your metabolism. All right, so just a little review here. Thyroxine increases the rate of metabolic reactions in your body, especially the glucose reactions. One thing you should know by now is glucose is broken down by cellular respiration to regenerate ATP for your body. So the more glucose that is broken down, the more ATP, the more usable energy you have, the more body heat is produced. That's just a little summary. Now, the other thing we said that thyroxine requires for iodine atoms to be built. So where do we get our iodine in our diet? Well, the source of iodine in our diet is seafood, and for us, iodized salt. But remember, in the history of humanity, iodized salt is sort of a new invention. So let's talk about the early settlers. Early settlers in America. The early colonists, at first they did live by the ocean, but then they began to migrate inland. And when they migrated inland, there was no seafood as a source of iodine, and obviously there was no iodized salt. And they developed a condition called a goiter. A goiter is an enlarged thyroid gland. So, have you ever heard of a goiter before? Have you ever seen anybody with a goiter? Perhaps not, but this used to be not an uncommon medical condition. So now we're going to fill in that little box on the right. How does an iodine deficiency cause the formation of a goiter? So goiter formation. If the hypothalamus senses low levels of thyroxine, again, there would be low levels of thyroxine because there is an iodine to build thyroxine. When the hypothalamus, which is always sensing blood hormone levels, senses a low level of thyroxine, it secretes its hormone, which is TRH. The TRH travels directly to the anterior pituitary. And remember, there's these little capillaries that lead directly from the hypothalamus to the anterior pituitary. So the TRH goes directly to the anterior pituitary and stimulates the anterior pituitary to specifically release TSH, thyroid stimulating hormone. This should look familiar. TSH is secreted into the bloodstream. It circulates throughout the blood, but it targets the thyroid gland. Do you remember what two things TSH stimulates the thyroid gland to do? One, it stimulates the thyroid gland to mitose, and secondly, so it still stimulates the thyroid gland to mitose, so we get more cells, but it's supposed to stimulate the thyroid gland to secrete thyroxine, but it can't do that because there's no iodine. So your body cannot build thyroxine. So this stimulus has not been reversed. There's still low levels of thyroxine. The hypothalamus releases more TRH. The anterior pituitary releases more TSH. The thyroid is stimulated to mitose and grow and to produce thyroxine, but it can't make thyroxine. You get in the picture? We keep getting more levels of TRH, more levels of TSH. The cells in thyroid keep mitosing and mitosing and mitosing until finally, boom, you get a goiter, an enlarged thyroid gland. And again, sort of an older picture. This used to be not an uncommon medical condition. Doesn't take much. You can do a little Google search. Goiters galore. There you have it. This is how an iodine deficiency causes a goiter, which is an enlarged thyroid gland. Now, goiters have been around for a long time, and they were not only recognized, but they were diagnosed in ancient Greece about 3000 BC, and the cure the Greeks described was eating sponges. So I want you to think for a minute, does this make sense? If you have a goiter, would eating a sponge be sense for a cure? Okay, now wait, I hope you're not thinking of bathroom sponge. You do realize I mean the marine animal? So yes, it's seafood. So eating a sponge would be a good cure for a goiter. Now again, the ancient Greeks, they had their act together. Let's fast forward to medieval time. Again, this is just sort of fun trivia. I don't care if you memorize this or not. In medieval times, they thought goiters were beauty marks. They thought these enlarged necks were beautiful. To each their own, right? They also had some really bizarre ideas what caused a goiter. They thought eating the bones of toads could cause a goiter, coitus interruptus could cause a goiter, or robbing the graves of a saint. Again, very bizarre ideas in my mind. All right, before I go on, what I'm going to cover next are what happens if your thermostat is set wrong. Basically, we all have our default setting of thyroxine levels, which works pretty well. But some people have usually a high default setting for thyroxine levels and some low. So I want you to investigate. I have a little short 1-minute video about the making of Young Frankenstein, and believe it or not, it has to do with this topic. See you then.